Hello learners, welcome to my YouTube channel again. I feel so happy teaching you brilliant learners. We are still on exponent and sets, and today we are going to talk about sets, lesson 4. When a root is irrational, it is referred as set. Irrational numbers are numbers that cannot be written as a fraction. Irrational numbers do not terminate or repeat. So if you have 0.12204, yes, continue. You can see that the numbers are not repeating as indicated in the example. So we have 0.231905675. We see these numbers that come after the decimal point do not repeat or do not terminate or end. When we do the same for the square root of 3, the square root of 5, the cube root of 17, using our calculator, we will see that these numbers do not terminate or end. How about the square root of 4, as indicated or underlined by the ink? Square root of 4 is not an irrational number because when simplified, the result is 2. It terminates or end. So to prove it, you can use your calculator, type or find square root of 4 and you will get 2. The following are set laws. We have the multiplication law and we also have the division law. So when doing multiplication of set, we multiply the radicals as indicated by the ink sign. A will multiply B, so we are going to have the nth root of AB. We do the same thing with the division law. We are dividing the radicals, so we are going to have the nth root of A divided by B. Let's take some examples and let's see how we can solve it. I am going to show you two ways of solving this, using the multiplication law and using the alternative way of also solving. Example 1. If we have square root of 2 multiplying the square root of 2, we multiply the radicals, the number inside the root. So we are going to have 2 times 2. We are going to have the square root of 4, and the square root of 4 is 2. The alternative way of solving, square root of 2 is the same as 2 to the power 1 over 2, and the other square root of 2 is also 2 to the power 1 over 2 as indicated with the ink pen. Remember when we were learning the basic laws of exponents, when the bases are the same and we are multiplying, we add the exponent or the index. So 1 divided by 2 plus 1 divided by 2. If we are to do workings, addition of fraction, 1 divided by 2 plus 1 divided by 2, we find the least common multiple of the denominators, and the denominators are 2 and 2. So the LCM, known as the lowest or the least common multiple, is 2. So 2 divided by 2 will give us 1, and 1 times 1 will give us 1. 2 divided by 2 will give us 1, and 1 times 1 will give us 1. So therefore 1 plus 1 is 2. 2 divided by 2 is 1. So we are going to have 2 to the power 1, and 2 to the power 1 is 2. Let's go to the second example. We also multiply the radicands, that is 2 and 3. So we are going to have the square root of 6. Here we are also going to multiply the cube root of 3 and the cube root of 9. So the multiplication law, we multiply the radicands, that is 3 and 9. We are going to have 27, and cube root of 27 is 3. It means that what number was raised to the power 3 times to get 27, and the number is 3? Or how many times can we multiply a certain number 3 times to get 27, and the number is 3? It is not 1. 1 times 1 times 1 is 1. 2 multiplied by 2 will give us 8. And 3 multiplied by 3 is 9. 9 times 3 is 27. Now we go to the division of law example. Division of said law example, we are having the square root of 9 divided by the square root of 3. We divide the radicands. We are going to have the square root of 9 divided by 3. So therefore, the final answer is square root of 3. The other example is we are going to have the cube root of 54 divided by the cube root of 2. We divide the radicands, so we are going to have 54 divided by 2, which is 27, and the cube root of 27 is 3. Sets can also be grouped into like and unlike terms. Like sets have the same degree. Unlike sets do not have the same degree. So example, square root of 2 and the cube root of 3 are unlike sets. We can also have addition and subtraction of sets, just like we have multiplication and division of sets. We have 3 square root of 5 plus 2 square root of 5. Here we add the numbers outside the root, which is 3 and 2. We are going to have 5 square root of 5. Here too we do the same thing. We are going to add the numbers outside the root, then we subtract also. So 10 plus 6 will give us 16, and there's a hidden number here, 1. So 16 minus 1 will give us 15 square root of 3. We can also simplify sets. Sets can also be simplified by multiplying the radicand, by simplifying the radicand in the radical or the root sign. We do so by finding the factors of the radicand that can further be simplified. So let's take a very nice example so that you'll be able to understand. For instance, we have the cube root of 54. How do we simplify? If you are asked to simplify, first of all, you have to find the factors of the radicand as I gave to you in the explanation. So the factors of 54 are the numbers that can divide 54 without a remainder. So we have 1. 54 divided by 1 is 54. 54 divided by 2 is 27. 54 divided by 3, 54 divided by 6, 54 divided by 18, 54 divided by 27, and 54 divided by itself is 1. So these numbers are factors of 54, because when we divide 54 by them, we are not going to get a remainder. And notice here, with example 1, we are talking about the cube root. So when we look at the factors of 27, we pick a number that when we find the cube root of it, we won't get what? A remainder. And that number is 27. Because when we find the prime factors of 27, we are going to get 3. And 3 times 3 times 3 will give us what? 27. That is the cube root. We find a number that when we multiply it 3 times, we are going to get 27. And the number is 3. That is why you see 3 to the power 3 there. And the cube root of 3 to the power 3 is what? It's 3. So 3 times the cube root of 2 will give us 3 cube root of 2. 27 to, how do we simplify? We are talking about the square root of 27. So we need to find the factors of the radicand, that is 27. And the factors of 27 are 1, 3, 9, and 27. So among the factors of 27, we pick a number that when we square, we are going to get what? We are not going to get a remainder. And that number is 9. So 3 to the power 2 will give us 9. And square root of 3 to the power 2 is 1. 1 times square root of 3 to the power 2 is 3. And 3 times the square root of 3 will give us 3 square root of 3. Now we have it in a fractional form. We do the same thing. We simplify the radicands. The first one is what? 48. We find the factors of 48, and among the factors of 48 is 16, because 16 is the number that when we find the square root, we are going to get what? A single number. We don't want remainders. So square root of 16 is 4, and 16 times 3 is what? 48. So we are going to have the square root of 4 is 4. Sorry, square root of 16 is 4. And 4 times the square root of 3 will give us 4 square root of 3 minus the square root of 3. And notice here, these ones are like said, so we can easily subtract. So we are going to have 4 minus 1 will give us 3 square root of 3. And when we go to the down, the square root of 27, you look at the example 2, and you follow the third question, that's the square root of 27. So we are going to have 3 square root of 3 divided by 3 square root of 3. When we cancel, we are going to get 1. So learners, that brings an end to today's studies. Please look forward to your next video. Will be on rationalizing the denominator. And please do not forget to subscribe and hit the notification bell. And please share the video with your friends. Thank you so much, learners. Have a nice day.